Hi everyone, we are still in the introductory topics leading to Calculus 1. In this video we will focus on the tangent function. The tangent function depends on the angle of reference, as it is actually defined as the ratio of the sine to the cosine function. In other words, tan of theta is sine of theta over cos of theta. Graphically, this also means the tangent can be interpreted as the slope of the line through the origin and passing through point xy of the unit circle. If you recall, the slope is defined as delta y over delta x, and if point P has coordinates x and y, then the change in y is y minus 0 over x minus 0. And finally, recall that in a unit circle, the y component corresponds to the sine of theta, and the x component corresponds to the cos of theta. Sine of theta over cos of theta is the tan. Alright, so here's our unit circle. Notice how the tan of 0 is equal to 0. You can think of it in two different ways. If you observe the coordinate point at an angle of 0 radian, you'll notice that the y-coordinate is 0 and the x-coordinate is 1. The sine is 0, the cosine is 1, and therefore the ratio is 0. You could also think of it as being the slope of the line through the origin and then through point 1, 0, and that is also a slope of 0. Okay? At pi over 4, so tan at pi over 4 is 1. Once again, you can think of it as being the ratio of the two coordinates of the point where the angle passes through. So notice how at pi over 4, the y and the x coordinate are both root 2 over 2, and therefore their quotient is 1. Also means that the slope of the line through the origin and the point at angle pi over 4 is 1. At 5 pi over 6, the tangent function has a value of minus 1 over root 3, which we can find by doing the quotient of the y over the x coordinate. Again, the signs match when you look at the slope of the line through the origin and this point, so definitely a negative slope. At pi over 2, we have a bit of an issue because trying to divide sine of theta over cos of theta will create a zero division, or a division by 0. Also recall that the slope of the line is undefined. One can observe that the tangent function is positive whenever the reference angle lies in the first or third quadrants. So any line through the origin in these quadrants would have a positive slope, and therefore the tangent would be positive. Whereas the tangent function will be negative in the second and fourth quadrants. Here are some other characteristics that can be observed about tangent values. Okay, so tan of theta is repetitive every pi radian. So the slope through the origin and through P is the same in opposite quadrants. So notice here how at a given angle or at its angle 180 degrees or pi radians later, the slope is the same. Here's the graph of the tangent function. So we can sketch the graph of the tangent by using theta as the independent variable. And you can compute different values of the tangent by referring back to the unit circle in order to plot the points. Observe how the tangent function has vertical asymptotes at pi over 2, followed and then repeated every pi radian. So either period pi radians further or pi radians previous. So in other words, k here is any integer value, positive or negative. This makes sense if you recall that the slope of the line through the origin and point P becomes infinite as the angle approaches pi over 2. So for instance here I've selected a point along the unit circle that is very close to pi over 2. Notice how the line through the origin and point P is practically vertical, and by the time point P is at pi over 2, then the slope will be undefined because delta x would be 0. Here are some features to keep in mind when observing the graph of the tangent function. Okay, so the domain of the tangent function consists of all real numbers aside from those that are at pi over 2 and multiples or integer multiples of pi further. The range consists of all real numbers, as the tangent function does go all the way down to minus infinity and all the way up to plus infinity. It's periodic, in this case with a period pi rather than 2 pi as it would be the case for sine and cosine. Just like for every other function, the notation that accompanies the tangent function can vary. For example, it would be quite acceptable to write y equals tan of x, even if the x and the y values are totally unrelated to the coordinates of the unit circle. It would simply imply in this case that x plays the role of the angle and that the result of tan of x is referred to as y. Other trigonometric functions and identities can be useful. As you've seen, the tangent itself is related to sine and cos, and a whole slew of identities can help you make connections between these functions and other functions. Now, it will not be necessary to necessarily prove all of these different identities, but they will come in handy in some circumstances. So perhaps keep this slide in mind when we refer to trig identities to perform certain operations.